Okay, in this video, we're going to use lab bolt to make a connection, right? So in this procedure here, you need to use 380 220 volt transformer in order to check the polarity. We have to check the polarity of the transformer. So there are two steps. Here we have a jumper wire at this point, and here we have a jumper wire on this point, and we will analyze the voltages connected to 380 voltage source. Voltage source is here, measure the voltage here, and also the secondary and the primary. So I have here, we need a 380 220. So the input here is 380, and the output here, it is center tap, not a center, but it is a multi-tap transformer. Here we have 220 between 0.4 and 5. So this is suitable to our requirement. In the first part, the jumper wire is from this point up to this point of the 220. So it can be from here up to 4, right? This is the jumper wire here to be connected to a source. Let's say this is the source. Consider that is 380. And then we are going to measure the voltage from this point up to this point. This is our voltmeter connected here and connected here. Okay? And we also need to measure this using our, let's say we use here in our lab volt, we use E1. We use E1 here to measure the voltage across this voltage. We can use E2 here, we can use E3 here to measure the secondary. On the second part, we need to make a jumper wire, right? Let us compare here. I'm going to use this one. The jumper wire between from this point to this point. This is to be connected to 380, 11 and 12. And we have a jumper wire here from positive, negative. We will measure this voltage going to that terminal. So we will measure this voltage going to the voltmeter. Okay? And you have to complete this table, write these values, and after that you can conclude where is the location of the dot. Right? Is it here? Is it here? Or is it here? You will know with this condition. Now, let us try to have some connection in the lab volt. Okay. So first of all, our jumper wire will be from, the first part will be from this point up to this point. So I'm shorting this wire. Okay. And I will be connecting this into a 380 voltage source. So 380, I can connect from here. Okay, I can connect from here, 380, right? Here we are not, we disregard the phase because we are just only testing the transformer. So now I have 380 here, and I'm going to measure, of course, the input voltage here, which is, I'm going to use same wire. So the input voltage here is being measured. Of course, we are going to set it into 380, right? 380. Okay. Oh, I think it's better to adjust the wire on this position. Okay. Now, let us also measure the voltage across secondary. Secondary, I'm going to use another color. Let's say white color. I'm going to use this voltage. Let's say I'm going to use E3 to measure the secondary voltage. To measure the secondary voltage. And I'm now going to use another wire. I'm going to use E2 to measure the B, right? Between 2 and 5, right? Let us try to adjust. Let us review our connection. This yellow wire is to measure the voltage 2 and 5, right? This is the B. Look at our figure. Here, this is the B voltage, right? So this pink wire here is measuring the voltage across the source, and the white is measuring the secondary. So we can now simulate this. So we have, actually I had connected this one, the gray wire. Of course, don't forget to connect it here and switch on this one. Switch on, switch. Okay, now on, it's illuminated, and switch on here, it is connected to a 380, right? 100% means 380. So now simulate the circuit. So it's automatically simulating. Now, here we have 398, the input. The V is 170, 227 is the secondary voltage, right? So this is for the first part, and you have to fill up the tables, this table here. This is on test 1. What about in test 2? In test 2, let us try to do test 2. Remove the cable. Okay. Undo. Okay. So I'm going to use now similar this one. I'm going to use here. It will be, the jumper wire will be here. Okay. The jumper wire will be here, and we will measure the voltage. We will supply voltage also. Okay, from this point up to this point. Okay, and we will measure that voltage. Similar procedure. The source, right? And we will measure the secondary. We will measure the secondary using. I'm going to use E3. This is the secondary, and I need to measure also what? The V here. So from this point, I'm going to use this one. Let me just adjust this wire because it's blocking. Oh, it's also white color. I need to change the color to blue, different color, blue. Okay, to measure V. Okay, now we have all the measurements, and we make sure that our voltage here is 380. I have 100% here. Everything is okay. Simulate. Okay. What happened to the voltage? Okay, we have a mistake. We have a mistake. With this blue wire here, it should not be here. So let's delete this wire. So it should be what? It should be in this terminal, right? 4. Okay? Because according to this connection, we have to measure this voltage. So now let's go and simulate. Simulate. Okay? Now what is the voltage? B is 604. Right? This is BS, B primary. The B and the B secondary. So you can now fill up this table in the lab module. Okay? Now, what about this circuit? This circuit, as you can see, we are using also 380 220. So that here we have 380 on this side. We use this at primary, and 220 here. Should be 220 on the secondary side. So, but of course, if we connected 380 here, what are we going to expect? There will be a voltage drop on these elements, right? So what will be the voltage here? It will no longer be 380 because there will be a drop here. So if this no longer 380, this one will not be 220, right? Across this terminal, if not 380 anymore from this point. This one will not be 220. It will also drop. Okay. So here is the connection which I already made. Let me just explain this connection and you can follow. So first thing what we should do here is from the source of 380, make sure that this is 100%. 380, I need to measure the current IP. I can measure current from here. I can measure this same current on this point, right? They are the same. They are in series. So from here, I just go to the ammeter, I1 positive and I1 negative going to the resistive load. This is the resistive load, 2,200. So it is down here 2,200 because the center one is 2,200. So it's the toggle switch here is on in series with an inductive load, also 2,200 here. And then it's going to this terminal of the primary, and the other side of the primary is going to go back to the source. So this red one going back to the source, right? Now, what else we need to do? Of course, we need to measure the voltage here, VP. We are going to use E1. So I'm using here E1 connected to in parallel with this primary of the transformer, just to measure the voltage here. Okay? And what about in the secondary? Of course, secondary, from here, it's going to, we want to measure the current. So we have current and then resistive load, capacitive load. So this current, look at the green wire here, going to the ammeter, I2 positive and I2 negative, going to the resistive load, which is this one, resistive load. So set this to this one, 1,100, and going down to the capacitor, 1,100 again here, and then going back to the secondary, and then which is this wire here, this wire here. So after that we will measure the voltage across the secondary using this white wire here, E2 measuring this voltage, and here measuring this voltage, right? So upon measurement, I simulated and then I found out this value. So this one, this part you don't need to connect it, it's already there. You just need to analyze the results, right? So, but let us go to another procedure. You have to fill up this table according to the results. We already have BP, IP. P primary is this one, right? P primary, B secondary, I secondary, and P secondary is this one. Okay? Now let us now go to this part. You are going to connect this. So it's more simple. You just remove these elements here. There is no resistive and inductive load. It's very simple, almost the same, but you need to determine the BP and IP. What is the purpose of this part? You need to know the reflected impedance. Reflected impedance will be equal to BP over IP, right? BP over IP, you can calculate reflected impedance. Or you can just calculate from here. By calculation, you can compare it from here. The procedure that I taught to you on the previous video, right? By doing the calculation, you can compare measured, calculate ZP by measured values, and calculate ZP using the previous procedure. Now, in this part, right, we have this actually here. We are going to use a 220 voltage source. We are going to connect it in this side. So if it's 220, here will be 380, right? Okay, the input here is 220 because this is 380, 220 voltage ratio. So if you have 220 here, this will be 380 here. You will have a voltage here, but you need to show the set as reflected impedance, right? Reflected impedance from this point. Calculate. Viewing from this, the set S. And the other one here is the input impedance from here. So now, you have to fill up this table, and from this part, remove 1,100 ohm in figure 9. Where is that figure 9? In figure 9, 1,100 ohm. So it has been removed from here. So we only have 2,200 ohm resistor. Where is this one here? Okay, just connect this one. Connect this according to your according to this figure. So you just calculate VP, IP, BS, IS, or calculate, or also use the voltmeters, the ammeter, E1, E2, E3, and I1, I2, any of this to complete this table, right? And then you have to go for conclusion and some calculation to complete your lab report.